Welcome. In this video I'm going to show you how to visualize limits that look like tan inverse of 1 over d. For example, as d approaches positive infinity. So this is a non-standard kind of approach, not a textbook approach. This is more a video for those who are interested in seeing past what you've learned in just basic calc, for example, or basic math. It's a way of visualizing this process. So first what I'm going to do is I'm going to use variable substitution. I'm going to set u equal to 1 over d. And then instead of writing tan inverse of 1 over d, I might say just tan inverse of u. And now, over here, I'm going to make some pictures. So I'm going to draw tan inverse, a small portion of it. So this is going to be, for example, I'm going to call this my u-axis over here, okay? So let's call this the u-axis. Okay, this is going to be my vertical axis this way. And I'm going to zoom in here. I need to be able to visualize things clearly. A little bit like that. Okay, so let's see. First of all, we don't need this portion right here. I'm going to erase that. That's my u-axis. Again, I'm going to make a picture of tan inverse. So for that purpose, this is basically, as you might remember, the upper asymptote, which is pi over 2. And that there will be the lower asymptote, which, as you might remember, is negative pi over 2. And then the tangent inverse, at least on this side, kind of looks like this. A very rough sketch by hand. So you basically take one branch of the tangent curve, and then you remember if you do rotate across y equals x, and I gave you a picture of tangent inverse. So that's this. This is the u-axis here. And now take a look. Somehow I need to relate u equals 1 over d to this picture here. So to do that, I'm going to show you the kind of non-standard way. I'm not sure that you might describe it as non-standard, non-conventional, perhaps a bit more creative. But the goal is to try to visualize the whole process of taking the limit all at once. So to do that, because u is defined to be 1 over d, down below this, I'm going to define a new graph that looks like this one. Take a look. Let me grab the arrow. This is going to be my d-axis now, pointing straight down. I need to grab a different color. Okay, so this is going to be my u-axis, pointing straight down, or rather d-axis, pointing straight down this way. This is d. So this is the d-axis going straight down. So here, down is towards positive infinity, just so you know that. Okay, across here, this is a direct copy of the u-axis from above, basically. So let me label this. This is the u-axis, like that. And take a look. What I'm about to draw right here, this represents the curve u equals 1 over d. So a rough sketch will look like this. This is 1 over d. Let's take it up a notch now. That looks like this. What I mean is the d-axis is in this lower graph, the vertical axis. So imagine that as a place to begin, d has this value. Okay, this is a value of d. I'm going to call this, let me zoom in, this is d0. So when d has the value d0, whatever it is, maybe it's 1 or 2, it doesn't matter, it's some number, okay? Then the output from that, and I'm going to do that in a different color here. You have to be kind of careful. So I'm going to use this. The output from that would be this arrow. It would take you to this curve. And then you shoot across the curve up to here. Take a look. So let me all the way to here, okay? Like that. And this over here, this is, let me switch my pen. This represents u, but this is, let's say, u0. This is 1 over d sub 0. You see that? So this is a value of u, but then that itself, let me grab the arrow, that's going to take you across this curve. And then across that curve over to about here, you see? So that will represent, now, take a look for a second, this will be tan inverse of u sub 0. Let me zoom out. You need to be able to visualize the whole process. So that's pretty much here. And let me put some numbers in there to keep track of what we've done step by step. So basically, this was step 1 over here. Let me grab a different writing. There you go, this one here. So it's going to be step 1. This was step 2 essentially, right? Then we came up to here, step 3, and this was step 4 right here. And now d, on the d-axis here, we're going to slide down towards positive infinity, okay? So let me repeat this. I'm going to grab a different value of d, maybe like say d1. So I'm going down this way on the d-axis towards positive infinity. When I do that, let me grab some different color arrows again. Okay, so it's going to give me an arrow this way, an output this way. This is going to give me an output over here to that. Okay, so over here, this is again, let me grab the pen and erase that last bit. So let me erase that. So this here is u equals, now we'll call this u1 equals 1 over d1. And then you got to continue that up to there. So let me grab the arrow back. That's going to give you the arrow back. So that's going to give me now the following. It's going to take me over to here, you see, on the u-axis, on the basic tan inverse curve. So again, let me emphasize that this here is u equals 1 over d1. So let's say it's u1. And lastly, that's now going to put us back out to here, right here. You see that this is the output. So that represents tan inverse of u1. And what I want you to get away with, or rather take away from this, is you see that as this occurs, you see that this value is sliding towards 0 right here, right? It's coming down towards 0, just the way you see it. So let me zoom out. I hope you can see the whole process. Let me number the steps one more time. So again, this would be step 1 essentially over here. This would be step 1. Let me erase that arrow. So this would be step 1, step 2, step 3, step 4, and then lastly over here, this output would be step 5. So if you follow the arrows literally, you will see that we can conclude the following. Take a look. Based on this, the value of this limit, I'm going to make this a bit thicker even, the value of this limit is 0. So I can also describe it by saying, using our graphs, that following is true. Okay, so as d approaches positive infinity, so that's a statement about the vertical axis right here. Okay, so d is traveling down this axis. As d approaches positive infinity, then next, I'm going to call this 1, the next statement would be that 1 over d approaches 0. So 1 over d approaches 0 is a statement about the values of u, because u is 1 over d. So u moves this way, okay? It's approaching 0, you see? Lastly, tan inverse of 1 over d also approaches 0. So let me put the arrow over here, I meant to say. So that's also approaching 0. And that is again a statement about the fact that these values approach 0 over here. So in one comprehensive fluid motion, I would say as d, I would describe it this way. As d approaches positive infinity this way, the output approaches zeros this way, and then the output on this axis approaches 0 this way. And that is what this 0 represents. Now, I've shown you an example where, for example, d approaches infinity, 1 over d approaches, as you can see, 0, and then tan inverse of 1 over d approaches 0 also. You can repeat this quite easily for other kinds of statements, not only this one. Do keep that in mind. But I will leave it here on your own. What you may want to consider is perhaps pause the video and figure out what this might be. Okay, on your own, try this. So limit as d approaches 0 from the right, tan inverse of 1 over d. What does this equal using pictures like these? I know what it equals, which is that basically it's pi over 2. But the question is, can you draw little graphs like that to convince yourself that it's pi over 2 rather than some other value?